Hi there, in this video we are learning how to find out the nth term of the quadratic sequence. So we begin with the first example, and with the first example we are having a sequence which has got the terms to be as 8, 23, 48, 83 and 128. So we have got the first 5 terms of the sequence. The first thing we're going to begin with is to find out the difference of the sequence. We clearly can see that this is an increasing sequence. So to find out how much is it going up with, the first term is with 15. The difference between the second and the third term is plus 25. To go up from the third term to the fourth term is plus 35, and from the fourth to the fifth one would be plus 45. Now, because we see that the common difference, the difference that we are having from between the first and the second term, or between the second or the third term, and further, it's different numbers. So, which clearly shows that this is not the linear sequence, because with the linear sequence, we know that the difference in the sequence would be the same. So once we would having a first difference and that's giving us some different numbers, we're going to find out the second difference of the sequence now. To find out the second difference would be now, if you find out the difference between 15 and 25 would be of plus 10. The other one would be plus 10 and the next one would be plus 10. So now the second difference is the same. So once you find out the first difference and you get the different numbers, then you do the second difference and you are getting the same difference, which indicates that the sequence is a quadratic sequence. To find out the first term of the quadratic sequence, we do the half of the second difference. I'm going to write it down over here that we do the half of the second difference. So here we are having the second difference is 10 and the half of 10 is 5. So the first term of this quadratic sequence would be 5n squared. The reason for writing down n square is because it's a quadratic sequence, and with the quadratic sequence, the power on n would be 2. Now, to find out that are we having some more terms of the sequence, we're going to draw a table. So to draw a table, I'm going to write it down. So what I'll be doing is the terms, which I say that with n, the first term is 1, the second term of 2, 3, 4, and 5. This is first, I'm going to write it down. The next is I'm going to write down the sequence terms. So the first term of the given sequence is 8. The second term of the sequence is 23. The next is 48, then 83, and then 128. Because we know the first term of this quadratic sequence already, which we found out is 5n squared, the next column would be of 5n squared. So now I'm going to find out the values for 5n squared. When you sub in n as 1, so 1 square would be 1 times by 5 would be 5. To do for the next one now, 5n squared when n is 2. So first you're going to do 2 times 2, which is 4, and then you do 5 times 4 would be 20. So the next term we are having here it would be 20. How you're going to find out the third one would be, you do the square of 3. So the square of 3 is 9 and you multiply it by 5. So 9 times 5 would be 45. For the next one would be 16 times 5 and that would be 80. So once we'll be having these terms, now what you can do is now you do the difference between the sequence with 5n squared. So the next thing which we'll be writing down over here would be the difference. Okay, so when I do the difference between them, difference is a takeaway, so I'm going to minus them together. So 8 take away 5 would be 3, 23 take away 20 would be 3, 48 minus 45 would be 3, and 83 minus 80 would be 3. And for definite, the next term we'll be having over here would be 125. And the difference of that would be 3 again. So we are having the common difference now, which is the same number 3, 3, 3, 3. Because we're getting the same term, so we're going to write down the nth term of this quadratic sequence would be 5n squared plus 3. Now I'm going to show you the next example, and with the next example we are having the terms of the sequence would be 3, 12, 27. So I'm going to write it down: 3, 12, 27, 48 and 75. Okay, to find out the end term of the sequence, first I'm going to find out that this is the increasing sequence. So every time is going up by which number? So to find out the difference, to go from 3 to 12, you do 12, take away 3 would be 9. It means when you do 3 plus 9, you would have 12. The other one would be 12 plus 15 is 27, then plus 21, and the next number would be plus 27. Clearly here we see that we are getting different numbers, so it's not a linear sequence. So because it's not a linear sequence, we're going to find out the difference one more time. So I'm going to find out the difference of these numbers now. The difference between 9 to 15 is plus 6, then 21 with 15 would be plus 6 again, and 21 plus 6 would be 27. Because we are getting the difference the same in the second time, so it means it is a quadratic sequence. And because it is a quadratic sequence, so the next thing we're going to do is we're going to half the second difference. So we are having the difference is 6. When we do the half of the second difference, which would be 6 divided by 2, that would be 3. So of my quadratic sequence, the first term which I'll be getting would be 3n squared. To see that now, whether we are having more terms after 3n squared or not, we can draw the table and we can see it. So now I'm going to draw the table. The first thing I do is n. N represents is for the number of the terms. So the first term, second term, third term, fourth term and the fifth term. Now you're going to write down the sequence terms. So the first term of the sequence is 3. The next term is 12, then 27, then 48 and then 75. Now the next column you're going to make is of 3n squared, which is the first term of your quadratic sequence. So you do first of all the square of 1. So 1, because n represents is the first column, you begin with the first one. So 1 square is a 1 and you multiply the 1 with 3 would be 3. To do for the next one now, because now n is 2 here, and to do the square of 2 would be 4. 4 times 3 would be 12. We do the same thing with 3. 3 square is 9. 9 times 3 would be 27. 4 square is 16 and 16 times 3 is 48. Then 5 square is 25. 25 times 3 would be 75. Now, as we have done in the previous example, to draw the last column of the difference. So the difference between each of them would be 0, 0, 0, 0, 0. Which clearly shows that the quadratic sequence we are having has just got the first term written as 3n squared. So this is the quadratic sequence. We are having the quadratic sequence is just 3n squared because the final thing we are getting is 0, 0, 0, where in the previous example we had plus 3 as the final, the common difference. Now I'm going to show you the next example where it could be possible that when you do the difference after making the table, you could have some different numbers. So we're going to see that what we're going to do if we will get the different numbers. So now here we are having a sequence with the numbers -2, 7, 22, 43, 70 and so on. Now I'm going to find out the first difference of the sequence. So this would be plus 9, this would be plus 15, this would be plus 21 and this would be plus 27. How to find out the difference is to show you with this term to this term between the third and the second term. For example, you do 22 minus 7 and that would be 15. To find out the difference between them two, you do 7 minus minus 2. 2 negatives makes a positive and that would be 9. So you can find out the difference between each of the two terms and you see that how the sequence is going up. Because we see that the first difference is not the same, from here we know that it is not a linear sequence. It means we need to find out the second difference of the sequence. So we're going to find out the second difference of the sequence. And now we see that every time it's going up by 6. Now because every time it's going up by 6, which is a same number, so which indicates that this is a quadratic sequence. And to find out the nth term of the quadratic sequence, first we do is the half of the second difference. So to do the half of the second difference, it's the second difference we are having is 6. To the half of that would be 3. So the first term of the quadratic sequence which we are having would be 3n squared. The reason for writing down n square is because it is a quadratic sequence and the power of the quadratic sequence highest is 2. Now to find out that either we are having more terms written after 3n square or not, we're going to draw the table. The table begins with the same thing. The first is for the n terms, so n values. The next would be the sequence values. So other one would be whatever you have in the first term of the sequence, which is 3n square. And the last row would be for the difference. Okay, I'm going to start by writing down with n. So the first term is 1, 2, 3, 4 and 5. Now the sequence terms are what's given us originally in the question. So it's minus 2, 7, 22, 43 and 70. Now we're going to find out with 3n square what are the numbers we are getting here. So we have done this previously in the previous question as well. So this n represents for 1. 1 square is 1. 1 times by 3 would be 3. The other one would be 2 square, which is 4. 4 times 3 is 12. Then we're having 3 square is 9. 9 times 3 is 27. 4 square is 16. 16 times 3 is 48. 5 square is 25. 25 times 3 would be 75. Now we do the step of finding out the difference. So we're going to take away them together. So we find out the difference between each of them. To find out the difference between each of them, we're going to see that what we are getting. So minus 2 and minus 3 would give minus 5. So when you do the difference between them, what do we see that is? We take away them together. So to take away them together, what we'll get is minus 2 and minus 3 is minus 5. Then 7 take away 12 is minus 5. 22 minus 27 would be minus 5 again. And we are getting as a same common difference of minus 5. Now, because we are getting the same term as a minus 5, simply we're going to write down the n term of our quadratic sequence would be 3n square minus 5. This is a question where again we are getting the same term. But we're going to see that what else they could possibly be asked in the question. They could even ask to find out the 10th term of this quadratic sequence. So because we get the sequence which is 3n square minus 5, I'm going to continue with that. So the n term of the quadratic sequence is 3n square minus 5 and they asked to find out the 10th term of the sequence. So the nth term of the quadratic sequence which we had in the previous part would be 3n square minus 5. Now to have it now, what you're going to do is they possibly could ask you that find out the 10th term of the sequence. So to find out the 10th term of the sequence, which means that n is 10, you're going to write down by changing n with the 10, so it would be 10th term equals 3 times 10 square minus 5. And you do the simplification after. So square of 10 is 100 and you're having minus 5. Then 300 take away 5 would be 295. So the 10th term of this sequence would be 295. Okay, we're going to do now the last example on finding the quadratic sequence. So to begin with the first, to do the last example now. So here's the last example. I'm writing down the numbers now. And the terms we are having of the sequence is 2, 9, 22, 41, 66. Okay. We're going to start with the first thing, which is, I'm going to rub this off and write it down properly. So the terms we are having is then 66. Okay. We're going to start by doing the first difference, finding the first difference between each of them. So this would be now plus 7, plus 13, plus 19 and plus 25. Again, because the difference is not the same, so it's not the linear sequence. We're going to find out the next difference from here now. So we'll be just finding out the next difference, but seeing that what number goes with it. So plus 6 each time. Because we are getting the second difference is the same, which shows that it is a quadratic sequence. And because it's a quadratic sequence, so we're going to halve the second difference. Because we are going to have the second difference, and the second difference is 6, so you're going to do 6 divided by 2 would be 3. So the first term of this quadratic sequence would be 3n squared. We need to find out that are we having some more terms of this quadratic sequence or not, or if then what are the next terms of the quadratic sequence. We're going to draw the table now. So this is n with 1, 2, 3, 4 and 5. Then we're having the terms from the sequence, which is 2, 9, 22, 41 and 66. Then we're going to get this, the first term which we get is 3n squared, and as we have done in previous so many examples that what we're going to get from there, so we'll be getting 3, 12, 27, 48 and 75. Once you would have that, now you'll find out the difference. So the step to do for the difference is, it would be 2, take away 3, so you minus each of them together. To find out the difference, you'll be getting minus 1, then minus 3, minus 5, minus 7 and minus 9. This example is different to what we have been doing before, because now this time the difference we are getting is a different numbers. We are not getting the same difference, so it means we're going to find out the difference of this sequence now. So we see that how the sequence is going down. Because it's a decreasing sequence, every time it's going down by minus 2. And because we are getting the same common difference with these numbers, it means it will come out with the linear sequence. To do with the linear sequence, we know the rule of this linear sequence is minus 2 each time. So we're going to start with minus 2 then. So this is minus 2 here. Now, minus 2n basically would be the first term of this linear sequence. But we're going to just take minus 2 for now and some number to add or take away into it to get minus 1. So in minus 2, when you're going to do plus 1, you'll get minus 1. So it means the next term of this linear sequence would be plus 1. We got the first term of the quadratic sequence, which is 3n squared. We got the next two terms, which is minus 2 and plus 1. So the final answer would be writing them down together. So the nth term of this quadratic sequence would be 3n squared minus 2n plus 1. I hope this video you found it useful in understanding how to find out the nth term of the quadratic sequence. And I've shown you different examples where the difference possibly could be like the same number, or it could be 0, or it could be different number. So this last example is where the difference was not the same number, and it's just when you find out the further difference of that, it would be minus 2, minus 2, minus 2, minus 2 each time, which is again leading to the linear sequence. You get your linear sequence and you have the first term of your quadratic sequence. You write them together would be the nth term of this quadratic sequence.